at the planet's southernmost limit, where ocean and ice merge in a timeless embrace. The cold does far more than harden the surface. It challenges the very limits of existence. Here, even breath turns to frozen crystals, and the sun remains only a brief guest across the year. Across the endless white expanse, hidden in waters dark as jade, a silent host moves. Without claws, without fangs, armed only with intelligence, cohesion, and tactics, which are the ocean's deadliest weapons. They are the Antarctic orcas, the unquestioned rulers of the chilliest seas, whose dominion rests not on raw might, but on intellect and flawless coordination worthy of any elite fighting unit. This is the tale of silent sovereigns, fighters of the icy deep, and the hidden civilization thriving beneath the thick ice. Warmth. Warmth. Welcome to this wildlife documentary, Antarctic Orcas, Lords of the Frozen Seas. Beneath the dense Antarctic ice, where sunlight seeps through only as soft, ghostly green bands, a vivid realm of sound unfolds. Deep moans, sharp whistles, unending clicks. This is the tongue of the orcas, the supreme hunters of the frozen ocean. They do not hunt alone. They are intricate families, clans with distinct cultures, shaped across thousands of generations in Earth's most severe environment. Today we enter the world of Antarctic orcas, where survival hinges on flawless teamwork, shared wisdom, and hunting methods so advanced they astonish human observers. A family pod of orcas glides through open water. This pod may consist of 5 to 20 members, yet the bonds among them are more complex than those of any land-based family. At the center resides the eldest female, the matriarch, an aged mother with decades of knowledge. She steers the pod through treacherous currents, instructing her young and grandchildren in reading ocean flows and detecting prey from a distance. Her offspring remain with the pod for life, preserving acoustic connections to their birth family. This is no random assembly. It is a lineage with a maternal system that can span 4 generations cohabiting. Communication underpins this bond. Each family clan possesses its own distinct dialect, a unique set of sounds understood solely by its members. Intricate whistles, low moans like a cello, and sonar-like clicks together create an underwater symphony. When a calf produces its first call, it is not a random noise. It mimics its mother, its grandmother, and the whole pod. Over time, the calf learns to adjust pitch and add nuances, eventually forming its own voice while staying part of the family chorus. Researchers have logged thousands of hours of audio and found that even pods living only a few hundred miles apart have markedly different languages, much like English and German in human society. But communication serves not only social bonds. It is also a hunting weapon. A pod spots a migrating group of humpback whales. Rather than charging at once, they orchestrate a true military operation. In the Antarctic summer, when melting ice forms narrow passages, the pod shifts to hunting seals, and that is when the wave-washing tactic is employed. Every member of the pod knows its exact role. Which one generates the wave? Which one blocks escape routes? Which one delivers the fatal strikes? This coordination demands a deep grasp of currents, body weight, and split-second precision. One error, a wave too weak, or a seal landing in the wrong spot, could leave the entire pod hungry for weeks. There are 4 main populations of Antarctic orcas, each representing a distinct story of adaptation and culture. Let us begin with Type A, the masters of the open ocean. These are the largest orcas, with males reaching up to 29.5 feet in length and weighing over 13,200 pounds. Their domain is the open waters far from shore, where they pursue massive prey like minke whales and occasionally young humpback whales. Their favored strategy is divide and conquer. A small group separates a calf from its mother while the main group constantly harasses the adult. The hunt may last hours, with the orcas rotating attacks, resting, then striking again. They know the specific weaknesses of each prey. For gray whales, they aim for the tail flukes to slow them down. For elephant seals, they attack the gills to cause asphyxiation. In contrast, Type B ice hunters are smaller than Type A but boast the most elaborate hunting techniques. The wave-washing attack we just described is their invention, yet they go sometimes they deliberately generate waves large enough to overturn entire ice floes, throwing seals into the water. To achieve this, they must precisely gauge the weight of the ice, the speed of the current, and the prey's position. Researchers once filmed a pod of ice hunters executing 17 consecutive wave attacks before succeeding, an astonishing display of persistence. Their primary prey are Weddell seals and crab-eater seals, species that specialize in living on the ice. Thanks to this unique technique, ice hunters can feed even in the harshest winter, when other groups must migrate farther to find open water. Type C fish specialists are perfectly adapted to dense pack ice. They are the smallest group, with males only about 19.7 to 23 feet long, and they specialize in Antarctic toothfish, which makes up 90% of their diet. Unlike others, Type C operates in narrow, ice-covered channels where movement alone is a challenge, let alone hunting. Their technique is pack hunting. The entire pod forms a living net, swimming in a V formation to herd the fish toward the center. They use sonar not just to detect fish, but to relay exact positions to one another. Each one knows the precise distance to the nearest fish and to the closest pod member. When the moment comes, they open their mouths together, creating a massive suction current that pulls hundreds of fish into their throats at once. This demands absolute synchronization in time and space, like a soccer team executing a flawless one-touch play. Finally, Type D, the enigmatic dwellers of the deep. They are the most mysterious in the Southern Ocean, rarely sighted, living in deep waters far from shore with a distinctly different physique. They have rounder heads, smaller dorsal fins, and eye patches so tiny they are nearly invisible. Their calls are entirely unique, high-pitched, prolonged whistles, almost like bird songs rather than whale vocalizations. Scientists have recorded only a few brief segments, but enough to recognize this as a completely separate language. Their diet remains a puzzle, but it is suspected they hunt giant squid and deep-sea fish. Some DNA evidence suggests this type separated from the others hundreds of thousands of years ago, evolving into a distinct branch with a unique hunting culture. The most remarkable aspect of the four types is how they transmit hunting techniques, a phenomenon known as cultural transmission in animal studies. Calves are not born knowing how to hunt. They learn from their mothers, grandmothers, and the pod. Consider a calf's first involvement in a wave attack. Initially, it only watches from a distance, learning to adjust its swimming speed, breathing, and breath-holding. On the second attempt, it might swim on the outer edge, creating small waves. Only after months and multiple hunting seasons does it join the tactical corps. This process can take 5 to 7 years, equivalent to a human child attending university. But culture is more than just technique. It is tradition. Every pod has its own habits. One prefers to hunt at dawn, another only when the tide rises. Some specialize in minke whales while others steadfastly avoid them. These differences are not genetic but the product of social learning. When a matriarch dies, her knowledge endures, passed to her descendants through thousands of shared practices. That is why conserving Antarctic orcas is not just about protecting individuals, but about safeguarding an entire culture on the edge of extinction. King penguins, a staple of the orca menu, bring a wholly different lifestyle, defense system, and hunting puzzle. In this frozen world, penguins are not merely food. They are tough instructors, catalysts for hunting innovation, and proof that even the smallest species can shape the tactics of the ocean's greatest predator. And today we follow these master hunters to discover how they turn diligent divers into a feast for survival amid ice and waves. Let us start with king penguins, the true princes of the sub-Antarctic. They stand just over 3 feet tall, weigh up to 35 pounds, and breed on ice-free peninsulas with year-round access to open water. Starting in April, as winter approaches, thousands gather on rocky coastal beaches, forming colossal colonies, sometimes up to 100,000 individuals, huddling in living blocks to protect eggs and chicks. Each one remains motionless for hours, turning toward the wind to share warmth, forming a pulsating mass like a giant breathing organism. Their resonant calls carry through snow-laden winds, an ancient chorus reminding us that life persists even in the harshest conditions. But orcas do not hunt adults. They wait for the chick's first departure from the nest, usually in spring or summer when open waters expand. At this time, the young princes gather in large groups at the water's edge, learning to swim, dive, and survive in the ocean. A pod of orcas approaches from afar, lying motionless underwater with only their dorsal fins breaking the surface like silent black watching shadows. They read the chick's swimming rhythm. Chaotic means unprepared, straight lines indicate basic skills, diving in large groups simultaneously signals an attack. The penguin wave tactic is executed with astonishing precision. A king penguin chick provides about 25,000 kilocalories, enough to sustain a young orca for several days and for the matriarch to rest and teach the next generation. An adult king penguin provides about 30,000 kilocalories. It is not much compared to large prey, but it is enough to maintain energy for long hunts between big feasts. In the sub-Antarctic winter, from June to September, sea ice expands, but king penguins still concentrate in open waters near the peninsulas. Chicks are the main target, with high density and narrow channels. Orcas expend 800 to 1,000 kilocalories per minute generating penguin waves, but success rates reach 80%. The chicks are not skilled at swimming and diving and easily become disoriented. Orcas spend 3 to 4 hours observing penguin groups before attacking, reading water movements, predicting wind direction, and calculating the positions of ice floes or rocky shores. The risk of injury is low, less than 5%, as penguins lack powerful weapons. In summer, from December to March, sea ice retreats, leaving vast open waters. King penguins remain a target year-round, but density scatters to just one bird per 2 to 4 square miles of water. Orcas expend less energy, 500 to 600 kilocalories per minute, by blocking paths or attacking individually, but success drops to 60%. They have only 10 to 15 minutes to detect travel routes, 5 to 10 minutes to surround, and 20 to 30 seconds to finish the kill. The risk of injury rises to 12%, primarily from the penguin's sharp beaks, capable of causing deep wounds. This shift is not merely tactical. It reshapes the entire social structure. In winter, orca pods operate like an army, with clear divisions of labor, iron discipline, and every movement executed at the matriarch's signal. In summer, they switch to special forces, flexible, creative, accepting higher risks for constant rewards. Calves learn to alternate between these styles, from winter patience to summer decisiveness, and from collective strength to individual independence. As sea ice has decreased by 12% in area over the last decade due to climate change, open waters near the peninsulas expand earlier, and king penguin chicks leave the nest 2 to 3 weeks earlier. As a result, orcas must switch from near-shore hunting to open water hunting earlier, expending 15 to 20% more energy. Some pods have developed a new jump hunting technique, generating continuous small waves to make penguins leap onto drifting ice floes or rocky shores, then waiting below with open mouths. Others learn to follow routes, swimming parallel to the penguins' daily migration paths, conserving energy by riding currents. But the penguins are adapting too. King penguin chicks learn to swim farther from the colonies, avoiding the shallow waters where orcas wait. They change their activity schedules, leaving the coast at dawn or dusk to disrupt the predators' routines. They begin swimming in small groups of 3 to 5, forming defensive formations, one on the surface keeping watch, others diving deep in search of food. Some groups even learn reverse decoy tactics, feigning a lunge toward the bait and then suddenly diving to depths of nearly 1,000 feet, leaving the orcas with empty mouths. This evolutionary arms race never ceases. DNA studies show that open water hunting orcas are developing genes to dive 10 to 15% deeper than previous generations. Meanwhile, king penguins are developing shorter, harder beaks to withstand the orca's suction. This is not just a race for survival. It is a biological dialogue spanning thousands of years between predator and prey. In the frozen world where ice and sea merge into one, orcas have no true enemies. But amid the freezing waters, there is another rival. Silent, agile, and a cold-blooded master hunter in its own right. That is the leopard seal. Both species share the same treasure: herds of seal pups, penguins, and small fish along the ice edge. When hunting season arrives, the line between hunter and usurper becomes very thin. Leopard seals are the only species in their genus, reaching up to 11.2 feet in length and weighing over 1,100 pounds, with spotted skin and a streamlined body like a living arrow. They do not live in packs. Each one is its own empire, controlling territories spanning dozens of square miles along the ice edge. Their teeth are an evolutionary masterpiece: 3 dagger-like upper canines for tearing flesh, 2 comb-like lower rows for filtering krill when necessary, and sharp incisors for crushing penguin bones. They dive to nearly 1,640 feet, hold their breath for 15 minutes, and sprint up to 25 miles per hour in short bursts, enough to outpace any underwater prey. But leopard seals are not just predators. They are ambush artists. They lie motionless beneath the breathing holes of Weddell seals, waiting for the steady vapor every 90 seconds. When the prey emerges, they explode upward like a steel spring with a precise bite to the neck and then a violent shake of the head to break the spine. For Adelie penguins, they hide beneath small ice floes, waiting for the birds to dive in like rain. When one strays, the seal surges from below, biting the soft belly and dragging it into the depths in an instant. No sound, no warning, just sudden death. Orcas, on the other hand, are collective strategists. They hunt in pods, using sonar to map the terrain, whistles to assign roles, and body mass to generate waves that knock prey off the ice. A 10-member pod can capture 20 penguins in 45 seconds or flip an ice floe to hunt Weddell seals. But this very sophistication, refined as it may be, creates underwater vibrations signaling to leopard seals that their territory is being invaded. The intersection of strategies is food. Both target seal pups in November and December, when they leave their mothers and learn to swim in shallow waters. Both hunt Adelie penguins along summer migration highways. Both filter Antarctic toothfish under thick winter ice. In a place where each prey yields only a few thousand calories, this overlap is no coincidence. It is an ecological conflict. A 1,000 square foot ice floe where 50 Adelie penguin chicks practice jumping. A pod of orcas approaches from open waters, preparing a penguin wave. But before they can strike, a leopard seal has been under the ice for 3 hours. As the orcas accelerate, vibrations spread. The seal detects it instantly. It surges upward, attacking the flock of penguins, first taking 5 and 10 seconds, then disappearing into deep waters. The orcas arrive a second late. Only streaks of blood remain on the ice and the panicked cries of the chicks. This is not a war. It is an interception. Researchers with underwater cameras recorded that in 100 hunts for Adelie penguins, 35% were stolen by leopard seals before the orcas could act. Conversely, in 50 hunts for Weddell seals on the ice, 28% saw the orcas knock the seals into the water only for leopard seals waiting below to claim the carcass before the pod could share it. No spilled blood, no roars. Just subtle shifts in the ecological balance. When leopard seals dominate high-density penguin areas, typically shallow channels near the peninsulas, orca pods must travel 60 to 100 feet farther in search of prey. A pod burns enormous daily calories just by moving, equivalent to many penguins. If a leopard seal controls the prime hunting grounds for a week, the orca pod can lose a large energy reserve, forcing it to switch to Antarctic toothfish, a lower-calorie food. Conversely, when orca pods hunt intensely at the ice edges using wave attacks, they break the ice, destroying the leopard seal's hunting grounds. An overturned floe can take 2 to 3 days to stabilize, during which the seal loses ambush holes and cover. A lactating female leopard seal needs several pounds of food a day. Losing territory for 5 days risks abandoning pups or starving to death. This is the competition between two apex predators at the same trophic level but at different scales. Orcas dominate the open ocean. They operate in deep waters, typically from 300 to 1,640 feet, and in shallow coastal waters to hunt. A pod can capture 100 prey in a day but needs vast space to maneuver. Leopard seals control the ice blocks and shallow channels. They operate at very shallow depths, usually 30 to 164 feet or less. An individual captures 10 to 15 prey a day, but only within about 2 square miles. The fragile balance between them prevents the Antarctic ecosystem from tipping. If leopard seals were to disappear, orcas would overhunt penguins and seal pups, collapsing populations. If orcas were to disappear, leopard seals would increase, but they would lack the capacity to control Antarctic toothfish, leading to a fish boom, krill depletion, and ultimately impacts on penguins. Climate change is tipping the balance. Sea ice has significantly reduced in area over the last decade, drastically shrinking the ice edge territory, the leopard seal's domain. Seals are forced into open waters, encountering orca pods more frequently. Conflicts have increased by 40% according to satellite data. Some young leopard seals are killed not for food, but to eliminate rivals. Conversely, orcas lose wave attack tactics on thinning ice, being forced to hunt in open waters where leopard seals have speed advantages. Some pods have shrunk from 15 to 8 members for greater flexibility. Beneath the Antarctic ice, where sunlight filters through only as faint and ethereal green bands, through ice layers several feet thick, every seal's breath, every penguin's dive, and every orca's sonar click is part of an intricate web of ecological balance where life depends on the harmony of all. The food web here is not a simple straight line. It is a complex circle forged over millions of years in the harshest environment on the planet. In Antarctica, the food chain begins with tiny but resilient producers, ice algae and phytoplankton, organisms that harness the weak sun's energy to feed the entire ecosystem. These provide energy for primary consumers such as Antarctic krill, the tiny crustacean so numerous it stains the ocean red, along with Antarctic toothfish and other zooplankton. Then come the secondary consumers, including Adelie penguins, crab-eater seals, and smaller fish, which eat krill and toothfish, transferring energy upward. At the top of the chain are tertiary and apex consumers like orcas, up to 29.5 feet long and weighing 13,200 pounds, leopard seals, 11.2 feet long and weighing 1,100 pounds, and humpback whales. These control the populations below, ensuring that no species becomes too abundant. Finally, decomposers such as marine bacteria, fungi, and marine worms break down carcasses and waste, returning nutrients to the currents and completing the ecological cycle. This web is not just a simple food chain but a complex system where each species depends on one another to maintain balance in the frozen ocean. Antarctica is home to over 10,000 species, each playing a specific role. Antarctic krill, Euphausia superba, is the foundation of the ecosystem with a total biomass of hundreds of millions of tons, one of the largest single-species biomasses on Earth. They eat ice algae, controlling phytoplankton growth, and serve as the main food for 90% of the marine animals here. Weddell seals, weighing 880 to 1,320 pounds, eat toothfish and squid, while crab-eater seals, the most numerous, estimated at tens of millions, specialize in filtering krill with comb-like teeth. Apex predators like orcas and leopard seals are key to the ecological balance. Orcas hunt seal pups, penguins, and large fish, controlling populations to prevent booms. Leopard seals hunt penguins and seal pups, competing directly with orcas, but on a smaller scale. Humpback whales, up to 52.5 feet long, eat krill and small fish, regulating krill without depleting the food of others. Krill is the primary food for many, from penguins to whales. A mature krill swarm provides abundant energy, enough for humpback whales to fast during migration. Their swarming behavior, with densities that block sunlight, increases survival against predators. However, they remain vulnerable when gathering near the ice, where orcas and leopard seals lurk. Orcas help control penguin and seal pup populations, preventing ecological overload. They also compete with leopard seals, sometimes attacking the smaller ones or stealing prey. In rare clashes, orcas have the advantage thanks to pack hunting and collective strength, but larger leopard seals can prevail with speed and ambush. Leopard seals regulate populations of Adelie penguins and crab-eater seals, ensuring secondary consumers do not overpopulate. They rival orcas at the ice edges, creating fierce competition in the food chain. Their presence makes penguins more cautious when entering the water. Beyond krill, orcas, and leopard seals, many others are vital. Adelie penguins, with over 5 million breeding pairs, eat krill and toothfish, controlling zooplankton. Antarctic toothfish, up to 5.9 feet long, eat krill and zooplankton, balancing deep water ecosystems. Seabirds like Antarctic petrels target small fish and krill, while giant squids eat toothfish, acting as ocean cleaners. Apex predators, orcas, leopard seals, humpback whales, are crucial for the balance. By hunting primary and secondary consumers, they prevent booms of krill, penguins, and seals. Without them, krill could devour the ice algae, degrading the marine ecosystem and impacting the entire chain. Competition between orcas and leopard seals also maintains the balance. When one overpopulates, competition intensifies, naturally adjusting the numbers of both. For example, if leopard seals increase, they reduce the penguins, pressuring the orcas' food, forcing both to adapt their hunting. Decomposers like marine bacteria, fungi, and marine worms are indispensable links. They break down carcasses and waste, returning nutrients to the currents. For example, when orcas or leopard seals leave prey remains, bacteria and worms clean them up, preventing disease. Ice bacteria break down dead krill, nourishing algae and completing the cycle. The Antarctic ecological balance depends on cascading effects. Breaking one link affects all. For instance, if krill plummets due to warming waters, penguins and humpback whales starve, reducing their numbers. This could cause the toothfish population to skyrocket, depleting zooplankton and altering the marine ecosystem. In the culture of Antarctic scientists, the food chain is a sacred circle of life. Krill symbolizes the small yet powerful. Orcas collective intelligence. Leopard seals fierce solitude. Researchers share stories of interaction, highlighting respect for nature to maintain balance. Some scientific accounts portray orcas and leopard seals as opposing spirits, embodying rivalry in the food chain. These are not just a research legacy but reminders of the fragility of the Antarctic ecosystem. Scientists study the Antarctic food chain to understand the interactions. Studies show that the decline of one species, like krill, triggers domino effects on penguins, orcas, and others. For example, ocean acidification that reduces krill could intensify competition between penguins and humpback whales, potentially causing both populations to decline. Ecologists emphasize the role of decomposers in sustaining the chain. Marine bacteria and worms not only clean carcasses but regenerate nutrients, ensuring the growth of ice algae, which are the foundation of the ecosystem. That seemingly stable world is more fragile than we think. As life revives through nutrient cycles, Antarctic natural disasters silently prepare another brutal challenge. The Antarctic summer, from November to March, turns the sea ice into a fractured labyrinth. Temperatures rise to 32 degrees Fahrenheit, a rare warmth melting the ice at breakneck speeds and losing thousands of square miles of sea ice annually. Massive icebergs miles wide break into fragments, creating sudden areas of open water called polinias. Here, deep cold currents upwell, bringing nutrients from the seafloor, nourishing ice algae, and kickstarting the food chain. Krill double their reproduction. Adelie penguins travel farther to hunt. Humpback whales gather to feast before the long winters. But polinias are deadly perils. Weddell seal pups drift away when the mother icebergs break apart suddenly. Emperor penguins must march over 30 miles in search of stable nesting ice. A misstep, a crack opening underfoot, can make a whole flock of chicks disappear instantly. In anomalous years, the thaw becomes devastating due to climate change. Recent thaws in the Weddell Sea have lost vast areas of summer ice, pushing species to the brink of the abyss. Thousands of penguin nests drowned. Crab-eater seal populations are critically endangered. The overturning of icebergs not only tests survival but alters currents, impacting the entire Antarctic food chain. Conversely, blizzards are the nightmares of winter. From June to September, winds reach nearly 124 miles per hour. Temperatures drop to 76 degrees Fahrenheit. Snow falls so densely that it obscures everything in minutes. The sea ice seals tightly, but storms create low pressure, cracking the ice into dangerous fissures. Temporary open waters refreeze rapidly, forcing species to take refuge in breathing holes or polinias to survive. Emperor penguins huddle by the thousands, rotating toward the wind to share heat, but chicks are easily blown away or freeze. Weddell seals maintain breathing holes in the storms, relentlessly scraping the ice with their teeth, exhausting themselves. Orcas get trapped under the thick ice, searching for cracks to breathe. One mistake, a crack refreezing too quickly, leads to mass asphyxiation. Climate change has increased the frequency and intensity of blizzards. In 2018 and 2023, Antarctica endured historic storms. Thousands of penguin chicks froze. Many orca pods faced starvation. Blizzards not only threatened life but increased the risk of ice cracking, the most devastating disaster of the frozen ocean. Ice cracking is Antarctica's greatest threat, especially combined with the summer thaw. A small crack from wind pressure or currents can extend hundreds of miles in hours. In 2017, the Larsen crack gave birth to iceberg A68, nearly 2,240 square miles, one of the largest on record. These cracks destroy habitats and kill millions. Adelie penguins and crab-eater seals on the ice fall in when the cracks suddenly open. Slow-moving Weddell seals have almost no escape. Orcas lose wave attack tactics on breaking ice and are forced to hunt in open waters, doubling their energy expenditure. Underwater shifting currents push krill farther away, causing toothfish and penguins to starve. Ice cracking alters Antarctica's carbon cycle. Sea ice reflects 80% of sunlight. When it breaks, oceans absorb more heat, worsening climate change. The consequences of cracking last for decades, and many Polonias cannot refreeze due to warming waters. Beyond the three main disasters, ice tsunamis are rare but horrific. When a massive iceberg overturns due to imbalance, it generates waves up to 33 feet high, extending for miles. Ice tsunamis can sweep flocks of penguins and seals off ice surfaces instantly. Orcas can dive deep to evade them, but surface-dwelling seals and penguins stand no chance. The thaw creates temporary open waters, Polonias, which increase local krill. However, overall the thaw reduces ice algae habitat, threatening major krill sources. Orcas lacking large prey switch to penguins, reducing populations by 30%. Blizzards seal breathing holes, exhausting Weddell seals and making them easier prey for orcas. But the thick ice hides the toothfish. Krill explodes, depleting ice algae. Cracking destroys habitats. Penguins migrate, krill shift, humpback whales starve, CO2 absorption decreases, and the thaw accelerates. Climate change is altering the Antarctic food chain. Rising ocean temperatures and melting sea ice reduce ice algae, affecting krill and primary consumers. This decline pressures penguins, seals, and orcas, unbalancing the ecosystem. Scientists predict that without timely action, Antarctica could reach a tipping point by 2050, when marine ecosystems can no longer sustain biodiversity. But we are not powerless. We can and must act, and that action must begin now. Marine protected areas are the first and most urgent solution. Currently, only 5% of Antarctic waters are protected. We need to expand them to at least 30% by 2030, according to UN commitments. Look at the Ross Sea Marine Reserve, established in 2016. Since then, toothfish populations increased by 20%. Krill stabilized. Orcas returned to regular hunting, with their whistles resonating under the ice once more. But we need more reserves, in the Weddell Sea, the Antarctic Peninsula, and the Drake Passage, which are critical feeding and breeding grounds. In these reserves, all exploitation must be absolutely prohibited. No krill fishing, no anchoring of cruise ships, only authorized scientists. This is the only way to safeguard the sanctuaries of life, where a krill swarm can feed thousands of penguins and where an iceberg can harbor hundreds of seal pups. Every ton of CO2 we emit is a piece of melted Antarctic ice. Sea ice has shrunk by 12% in area over the last decade. If global temperatures rise 3.6 degrees Fahrenheit, 2 degrees Celsius, 50% of summer ice will disappear by 2050. This means there will be no stable Polonias, no icebergs for seal breeding, and no orca hunting tactics. We need stronger climate policies. Nations must commit to reducing emissions by 45% by 2030 and to net zero by 2050. They must prioritize transitions to renewable energies, such as wind, solar, and tidal. Heavy industries must adopt carbon capture. Every nation, city, and individual has a role. Reduce single-use plastic. Switch to electric vehicles. Plant trees. Save energy. Antarctica has no borders. Greenhouse gases from Chinese factories, American cars, and Brazilian wildfires contribute to the melting here. Reducing global emissions is not optional. It is an obligation. It is our planetary responsibility. Antarctic krill is the foundation of all life here. Hundreds of millions of tons of immense biomass feed 90% of Antarctic marine animals. But krill fishing is expanding rapidly. In 2023, over 400,000 tons were caught, primarily for animal feed and omega-3 oil. We need sustainable management. The Commission for the Conservation of Antarctic Marine Living Resources must reduce krill quotas to 50% of current levels. Fishing zones must be at least 62 miles from penguin and whale breeding grounds. Satellite tracking technology must ensure no vessel enters the reserves. Ship noise is an invisible but deadly threat. Orcas use sonar to hunt, communicate, and locate calves. Engine noise from cruise ships, research vessels, and fishing boats disrupts their acoustic system. A 2022 study showed that with ships within 6 miles, orcas reduced their hunting efficiency by 50% and stress hormones increased by 30%. We need strict rules. Cruise ships must maintain safe distances, generally from 328 to 1,640 feet, depending on the species, never approaching hunting orca pods. Ships must reduce speed to 11.5 miles per hour in sensitive seas. Routes must avoid feeding and breeding grounds. Noise reduction technology, such as electric motors and improved propellers, must be mandatory. Antarctic tourism grows by 15% annually. We cannot ban it, but we must control it. Every tourist must be educated on wildlife approach rules: no touching, no feeding, no noise. Every trip must contribute to conservation funds. Let tourism be an ally of nature, not an enemy. We cannot protect what we do not understand. Research is the foundation of all conservation. Deploy underwater microphone networks to monitor orca calls, detect early behavioral changes due to melting, and sample DNA from feces, skin, and breath to understand the genetic diversity of ecotypes and predict climate adaptation. Tag orcas, leopard seals, and penguins with satellite trackers to map migrations and identify key feeding grounds. Expand research stations like Rothera, McMurdo, and Palmer, tripling Antarctic research funding over the next decade. Every discovery, such as a new hunting technique or a changed migration route, provides data for effective policies. Millions of people have never seen Antarctica, but they can save it. Invite the public to citizen science. Analyze satellite images of melting ice. Record whale sounds and report on penguins through mobile apps. Bring documentaries, exhibitions, and lessons about Antarctica to schools. Tell children about the orca matriarchs leading families through blizzards and emperor penguins marching 62 miles to protect eggs. Support conservation organizations like the World Wildlife Fund, Ocean Conservancy, and the Antarctic and Southern Ocean Coalition. Every dollar is ice saved, krill protected. One more day of orca whistles. Beneath the Antarctic ice, the symphony endures, but it is fading. Orca groans become arrhythmic. Penguin cries grow weak. Ice cracking accelerates like never before. We are the last audience for this masterpiece. We can choose silence and let it end, or stand up, act, and let the symphony resonate forever. Protect marine reserves. Reduce emissions. Manage fishing sustainably. Keep the oceans quiet. Research, educate, act. Because Antarctica is not just a continent of ice. It is the heart of our planet. And if that heart stops, the world grows cold. Act today for the orcas, for the penguins, for the krill, for our future. Like the video, share this life or death journey, and subscribe to join more animal documentaries where nature tells the slowly forgotten stories.